So we now look at joint continuous distributions. So all the properties for discrete applies for continuous, except that for continuous we get by integrating. For discrete we get by summing. So just a recap. So we are saying the PDF is f of xy is equal to the integral of Ox, the integral of Oy, f of xy, dy dx. So that's how we get the function. And then just some properties. First one is that this guy must be greater or equal to 0 for all xy. Second is that when you integrate for all x, you also integrate for all y. What must we get? We must get 1. Then from there, we look at the marginals, the marginal probability function. So the first one is f of xx. It's just the integral over oy, f of xy, dy. Then you also need f of y. So you integrate over ox, f of xy, dx. So now we can look at an example. So even here, it's the same thing. If x and y are independent, then we are saying that f of xy should be equal to f of x, f of y, like that. So we got next, we'll look at the example now. So let x and y be continuous random variable with PDF f of x y is equal to k x plus y for 0 less or equal to x less or equal to 1, and for 0 less or equal to y less or equal to 1. Then find the first one, find k. So you know that to find k, you need to integrate for all x, for all y of this function, dy dx, and we must get 1. So from 0 to 1, from 0 to 1, implying that from 0 to 1, from 0 to 1 of k x plus y dy dx, this must be equal to 1. So k can be outside, it's a constant. From 0 to 1, we have xy plus y squared over 2. And this is from 0 to 1, and then the x. This must give us 1. So we have k 0 to 1. When we substitute, we have x plus 1 over 2. Now with respect to x, it must be 1. So again, we have k x squared over 2 plus 1 over 2x. From 0 to 1, it must be equal to 1. So from here, we have k half plus half minus 0. It doesn't matter. So you can start with dy dx, especially that the limits in this case are the same, 0 to 1, 0 to 1. But even if they are different, for as long as they are constants, you can start with any, depending on which one is easy to integrate. So I have this is equal to 1, so that we have k half plus half is just 1, so k is 1. So now what we have as a function is x plus y, provided x is in here and y is in here. Then to find the probability x is less than 1 over 3 and y is less than 1 over 2. So remember how we are finding these probabilities? So it means that we have to move from 0 to 1 over 3 for x, from 0 to 1 over 2 for y, and the function is just x plus y, dy dx. So we have from 0 to 1 over 3, xy plus y squared over 2. It's moving from 0 to 1 over 2 dx. When we put half, we are from 0 to 1 over 3. So we're going to have half x plus 1 over 8. So where there is y, when we take half, it's 1 over 4. 1 over 4 divided by 2, it's 1 over 8. And then when we substitute 0, it gets 0 zeros. So we just have this dx. Then we integrate again, we get x squared. So let's just say x squared over 4. So we're going to have x squared over 4 plus 1 over 8x. And here from 0 to 1 over 3. So we have 1 over 9 over 4 plus 1 over 8 by 1 over 3. So what we get is 1 over 36 plus 1 over 24 minus 0, 0. And so these must give us, the common denominator should be 72. 36 goes in 72 twice. So we have 2 plus 24 goes in 72 3 times. So we have 3, so that we get 5 over 72 as required. Then we find the third, find the marginals of x and y. So we start with the one for x. which is the integral of OY and f of these functions with respect to y. That is from 0 to 1, x plus y dy, which is xy plus y squared over 2 from 0 to 1, and this is just x plus half, provided x runs from 0 to 1. So we put that because we are dealing with x. Then f of y, that is ox, f of xy dx. That is from 0 to 1, x plus y dx, which is x squared over 2 plus yx from 0 to 1. And this is 1 over 2 plus y, provided 0 is also equal to y, that's equal to 1. So that's how you get the marginals. Then the fourth one, we're looking at the probability x being less than y. So you know that for us to compare in this way, we need to start from the line x is equal to y. And then we'll pick the less part. So if you are to draw this line, when we are doing the assignment, so you draw this line, so this is x is equal to y, so x is equal to y here. So we're looking for the part x less than y. So we know that when x is 1, y also is 1. Now we want to look at this region, this part, where x here is less than 1. Okay, so if we picked, so here we could pick in n order. If we want, we are picking the integral. So if you want, we can pick x from 0 to 1. So this is x. And then pick y from the line, y is equal to x to 1. So you are going that way. From the line, going to 1 like that. So the function x plus y dy dx. So that we get x is 0 to 1, and then you have xy plus y squared over 2 from x to 1 dx. So this becomes, I can now say 0 to 1. So we have x plus 1 over 2 minus x squared so we are saying what depends here is the order. If you want, you can pick x to be bounded by the constants 0 and 1. And then for y, you are starting from the line going to 1. And the line is y is equal to x. Or you could change. So now let's just finish this one. Then we'll see if when we change, we get the same thing. So we have x squared minus x squared over 2. This will be dx. So I'm just squeezing there, I don't have space. So we have, when we integrate it, we have x squared over 2 plus half x minus x3 over 3 minus x3 over 6. So this is coming from 0 to 1. So we have 1 over 2 plus 1 over 2 minus 1 over 3 minus 1 over 6. So this is 6 down, and 2 there. We have 3 plus 3 minus 2 minus 1. So that we get 3 plus 3, that's 6. 6 minus 3, we get 3. So we get 3 over 6, and this is 1 over 2. Or you could as well say, for me to get x less than y, I want to get y from 0 to 1. So x is going to be from 0 to the line. So x will be moving in this direction. From 0 to the line, x is equal to y. X plus y. And dx, dy. So you can change the order. So this is y from 0 to 1, and then x squared over 2 plus yx from 0 to x. I mean from 0 to y. So you substitute, you have the integral from 0 to 1 of y squared over 2 plus y squared, and then dy. Then you integrate. So you're going to integrate again, you get y3 over 6 plus y3 over 3 from 0 to 1. And this is 1 over 6 plus 1 over 3, which is 6, 1 plus 2, which is 3 over 6. And this is 1 over 2. So depending on which one that you which order you take. So we'll also do this in calculus. We'll see how we'll be changing the orders if it's given in a manner that you cannot easily integrate. So you can play around with the limits, and then you change the order, and then you integrate. So do we have any questions? Okay, if we have no questions, then we can end here.